I now want to work out with you a rather detailed example of something in which we combine what we have learned today, down-to-earth problem, the kind of a problem that you might see on an exam or on an assignment. We hang an object on two strings. And one string makes an angle of 60 degrees with the vertical, and the other makes an angle of 45 degrees with the vertical. So this is the one that makes an angle, 60 degrees with the horizon, 30 degrees with the vertical. And this one, 45 degrees. Let's assume that the strings have negligible mass. So they are attached here to the ceiling, and I hang here an object M. Well, if there's an object M, for sure there will be a force mg, gravitational force. This object is hanging there, it's not being accelerated, so the net acceleration must be 0. And so one string must be pulling in this direction, and the other string must be pulling in this direction, so that the net force on the system is 0. Let's call this pull for now T1. We call that the tension in this string, and we call the tension in this string T2. And the question now is, how large is T1 and how large is T2? There are various ways you can do this. One way that always works, pretty safe, you call this the x direction. You may choose which direction you call plus. I call this plus. I call this negative. And you could call this the y direction, and you may call this plus and this negative. I know from Newton's second law, F equals ma, that there is no acceleration, so this must be 0. So the sum of all forces on that mass must be 0. These three forces must eat each other up, so to speak. Well, if that's the case, then the sum of all forces in the x direction must also be 0, because there's no acceleration in the x direction, and the sum of all forces in the y direction must be 0. And so I'm going to decompose them, something we have done before. I'm going to decompose the forces into an x and into a y direction. So, here comes the x component of T1, and its magnitude is T1 times the cosine of 60 degrees. Yeah. Now, I want to know what this one is. This one is T1 times the sine of 60 degrees. This projection, T2 cosine 45 degrees, and the y component, T2 times the sine of 45 degrees. So, we go into the x direction. In the x direction, I have T1 cosine 60 degrees minus T2 cosine 45 degrees equals 0. That's one equation. The cosine of 60 degrees is 1/2, and the cosine of 45 degrees is 1/2 square root 2. Now I go to the y direction. This is plus, this is minus. So we get one component here, which is T1 times the sine of 60 degrees, plus T2 times the sine of 45 degrees minus mg is in the opposite direction must be 0. That's my second equation. The sine of 60 degrees equals 1/2 square root 3, and the sine of 45 degrees is the same as the cosine 1/2 square root 2. Notice I have two equations with two unknowns. If you tell me what m is, I should be able to solve for t1 and for t2. In fact, if we add them up, it's going to be very easy, because we lose this, because we have both 1/2 square root 2, and so you see immediately here that 1/2 times t1 plus 1/2 square root 3 times t1 equals mg, and so you'll find that the tension 1 equals 2 mg divided by 1 plus the square root of 3. I can go back now to this equation. T1 times 1/2 equals T2 times 1/2 square root of 2. I lose my half, and so T2 equals T1 divided by the square root of 2. So the bottom line is, you tell me what m is, I tell you what T1 is, and I tell you what T2 is. Suppose we take a mass of 4 kilograms, m equals 4 kilograms. So mg is around 40. If we make g 10 for simplicity, then T1, if you put in the numbers, is about 29.3, and T2, 29.3 newtons, and T2 is about 20.7 newtons, I believe.